using dynamic routing via BGP, you have 50 megabits per second at minimum, up to 10 gigabits per second. And another security consideration is that it's not all. Now, the list of steps to implement an express route are short, but in reality, this is a lengthy process. You have to create an express route circuit, then you give your service key to your provider, and you create a peering configuration next. And this might be a part of this step 2 if the provider only offers a layer 3 connectivity rather than layer 2. And then you will create a gateway of the type of express route, and you will deploy that into your gateway subnet, much like Azure VPN Gateway. So now that we've talked about the benefits and security considerations, as well as the implementation steps of ExpressRoute, let's take a look. To Microsoft Edge via these ExpressRoute circuits. And then our ExpressRoute circuit, and that connection is coming from our ExpressRoute gateway, if you will. This gateway that we deployed in our gateway subnet of the type of ExpressRoute, and this connection with the Microsoft Edge allows us to have a connection to our virtual networks, as well as the resources on a Microsoft cloud. So now that we've taken a look at the architecture for an express route deployment, let's go ahead and hop into the portal and walk through setting up an express route. All right, gurus, welcome to the Azure portal, where we're here to go through to finish out this deployment. Just due to the nature of the cloud sandbox, it's not possible. However, we will be able to get familiar with the steps that we would take. Let's go ahead and get started. If we head up to the top here and we type in express route, we'll choose express route circuits because this is the first step in our implementation. We're going to choose create express route circuit. We'll choose our resource group, leave the default region, and give it a name. We'll call this express route. Then next we'll choose configuration, and we can choose between our port type. We could choose between provider or direct. And if you're choosing provider, you can choose between a list of providers here. We would select our SKU, and the SKUs are either local, standard, or premium. Now, premium is going to provide support for more than 4,000 routes with the ability to connect to more than 10 virtual networks. It's going to give you that global connectivity. So you're going to select your billing model, and your billing model is going to be between metered and unlimited. Now, unlimited is going to provide outbound data transfer for a fixed monthly fee. And then the metered, you're going to be paying a predetermined rate on the traffic going out. Now, all the inbound data transfer is a free of charge. Then we'll go ahead and we would select review and create. And this will go ahead and fail validation simply due to the fact that we didn't select a provider. But if you did, it would go ahead and create this express route circuit. You then give your service key to your provider and then create the peering configuration. And this was the part where I said it would be on the provider. We offered layer 3 connectivity rather than layer 2 to create the peering configuration. Then we would go and we would deploy, select express route, and follow the same deployment method we would in a site-to-site setup, but just setting up our express route. And then we could create our connection from our virtual network gateway express route to our express route circuit. And then that would finish our deployment. So this is walking through the steps of how we would go through implementing an express route. I had a great time. Let's make our way back over to the slides and let's review. All right, gurus. So in wrapping up in this video lesson, configuring express route, what we did is we talked about what express route is and why we might use it. We then talked about some of the benefits and security considerations with express route architecture and configuring an express route. I had a great time in this lesson, and I look forward to seeing you in the next one.
Come back to this lesson on Azure Application Gateway. Listener that would redirect traffic based upon IP address rules, source of destination IP addresses and ports, and then redirect based upon a set of rules. The Azure Application Gateway can not only do that, but it can also look inside the header and make routing decisions based upon the header that it sees inside the HTTP request. Mainly, Microsoft wants to ensure that you know that an application gateway is made up of a front-end IP, a listener, a set of rules, and then a back-end pool. Those are the 4 components that make up the Azure Application Gateway. Your configuration. What are you trying to accomplish with your Azure Application Gateway? Are you trying to load balance a web service? Are you trying to redirect video traffic to a different backend video pool? those types of configuration designs. When we take a little deeper look at the Azure Application Gateway components, we find that the front-end IP, this could be a public IP or a private IP that's tied to the listener. On the listener, it has a port IP and certificate. If you want to redirect encrypted traffic without decrypting it to a different destination, you would use the SSL offload and just listen for a particular port and redirect the traffic without decrypting it to the next hop. For the other traffic, the listener is going to use the application gateway. And from there, we have a set of rules. The rules stitch the front end and the back end traffic together. So we ensure that traffic that's destined for the front end goes to the correct back end, and traffic coming from the back end goes back to the right session coming through the front end. So we ensure that that traffic stays connected. That can help us with things like stickiness. We want to ensure for, say, a payment gateway, that once you start a payment transaction, that traffic always goes to the same payment application gateway server so that you're not starting a new session, because we want to keep that session secure end to end. There are other things we can do, such as setting up a health probe so that we can see the status of not only our backend pools, but our listener and our front-end IP. We want to ensure that everything's up and running and alert if something's not working correctly. A set of virtual machine scale-out servers, could be a VM pool, could be another load balancer internal if you're load balancing the traffic from the, say, an external web application gateway to an internal load balancer that's in front of your traditional web servers. And so we can do any of those based upon a rule that we define inside the listener. So we have our front-end IP, listener, our rules, and our back rules. In addition to this, we have the option to our rules. And it also can protect against any kind of command injection, such as a request smuggling or HTTP response splitting. So this can be very helpful in protecting your web application from hackers. Our Azure Application Gateway has two modes of routing. The first mode that we want to talk about is path-based routing. This is where we look inside the header and we see that the destination is contoso.com/images. And so we've set up a route that says anything/images and later goes to this image server pool, and anything ensuring that you can optimize your server pools for the type of traffic that you want to host. And you don't end up having to create multiple IPs or any kind of weird session state. We can do that all within the application gateway in the path-based routing. The second routing capability is the multiple site routing. The second routing capability is the multiple site routing. And this is nothing more than we're hosting multiple domains on top of the same public IP in the same application gateway. So we have contoso.com and we have fabricam.com, hosted by completely different sets of infrastructure, different ones on a web app tier and the others on a set of virtual machines. And so we can send them to two different destinations, even though they're all hosted on the same public IP and using the same listener. We just create different rule sets and different backend pools. And so that's multiple site routing. So we have path-based site routing that make up the application gateway routing capability in Azure Application Gateway. So that's the key concepts that you need to know for the exam. This completes this video lesson. I'll see you on the next video lesson. This session, we're going to talk about WAN connectivity. So let's get started. If I want to connect my on-premise network to Azure, because I've relocated a bunch of my servers now in the public cloud, and now I need a faster connection than what I can get over the internet. I can extend my private network into Azure using a service called ExpressRoute. And what ExpressRoute does is it's a highly available service that Microsoft offers via its partners to connect your corporate network with the Microsoft Edge. And when you connect up the ExpressRoute circuit, all traffic, regardless of offers, all of the traffic for your corporate enterprise will go over this ExpressRoute connection. And so it's a very handy service, especially if you need faster bandwidth for your enterprise. ExpressRoute is available starting at 50 megabits per second and going all the way up to 10 megabits. Slide are the ExpressRoute drop-off points from Microsoft's network to the partner network. And the orange dots are the ExpressRoute national cloud peering locations. Global connectivity with ExpressRoute is a premium add-on, and then billing is offered either in unlimited, metered, or premium. All of the ExpressRoute offerings include layer 3 redundancy. So I've got 2 layer 3 paths for every ExpressRoute circuit. So thinking about maybe you've got an existing VPN gateway with some IPsec tunnels between data center locations that you're hosting your gateway. So thinking about an organization that wants to migrate, maybe you've got an existing VPN gateway with some IPsec tunnels between a couple data center locations that you're hosting your resources in, and you decide you're ready to take the step of adding ExpressRoute. How do I make this work? Well, we can coexist site-to-site VPNs along with ExpressRoute. This would allow us to have 2 separate virtual network gateways to the same network. We could either do it via costing or by source destination IP. We've got a couple ways to map the traffic based upon what we're trying to accomplish. We could use this ExpressRoute as primary and then fail back to site-to-site VPN if ExpressRoute were to go down. Microsoft offers 2 SKUs for it, basic and standard. The basic virtual WAN is a way, if you have multiple sites spread across multiple subscriptions, it's a way to bring it all together and fail back to Site VPN if express route were to go down. And finally, Plans is a new service that Microsoft offers. There's two SKUs in standard. The basic offers, there's two SKUs for it.
SKUs for. Yeah, man.
Basic and standard. The basic virtual WAN is a way if you have multiple site-to-site VPNs spread across multiple subscriptions, it's a way to bring it all together with a virtual WAN. It allows us to integrate connectivity with this hub spoke model, and it allows us to visualize the end-to-end network flows within Azure. Virtual WAN standard adds the ability to add express route connections, like in our picture here. So I've got an express route connection quarters, and it also allows us to integrate in end user connections from point to site VPN. So I've got those users coming in here, and then I've got some branches, I've got applications distributed across multiple VNets across the world in Azure. I can bring all this together in a single intuitive interface that allows me to manage this holistically. And typically in a large organization, your network team would be very excited about having this capability as a way to bring together all of the end user endpoints into a tool that can then be used to monitor and visualize the network traffic from end to end. Again, there's two license SKUs, the basic and then basic is site to site, what you need to add if you want point to site users or express route. This completes this lesson on WAN connectivity and closes out the section on inter-site connectivity. I'll see you on the next section when we talk about network traffic management.
すごいな。 げえな。
Welcome back to this session on network routing and interfaces. Let's get started. When you build a virtual network, automatically Microsoft is going to create some system routes in that virtual network once you add your subnet. So for in this example, subnet, the minute I connect up my red subnet to the internet, and I'll have a default route out to the internet for workloads to be able to access the public internet. And this is done automatically without you even doing anything, even if you're creating this as a virtual machine through the virtual machine wizard where you create the VNet and the subnet. It automatically gets built. So in the example where I go and add another blue subnet, I'm going to get both of these subnets are connected up automatically. But what about the communication between them? Well, because they're on these two subnets, the red and blue subnets are on the same virtual network, they're automatically then connected. So red subnet can talk to blue subnet and vice versa. And all of the devices are automatically added via the system routes. So it's just important that you understand that all of this is done automatically. And it's done when you add the subnet. So whenever I go in and add a subnet, and this 100 net and this 5 addresses gets reserved. And part of that 5 addresses is one of them gets assigned for the gateway. And then you can associate this subnet with a route table here in this or network security group. And that allows you to associate it so that you can by what routing you want this individual subnet within the virtual network to do. How do you want the traffic to route? So you can have multiple subnets associated with a route table, but a subnet could only be associated with one. And so this requires you to think through this and do a little bit of planning as you're planning out your networking in Azure, but it's very easy to set up the networks between these. And Microsoft handles a lot of the automatically for connecting devices and services, and you don't have to think about it. But if you want to make changes here of our red net subnet and our blue subnet, I've this red subnet server here to a virtual appliance. It's a firewall appliance. And in this example, rather than routing the traffic, both having access to the internet, I want to force the blue subnet traffic to traverse through the red subnet appliance before it goes to the internet. So I don't want the blue subnet to have internet access. And so if I want to do this in this configuration, what I need to do is I need to add a route table. When I add this route table, then I can tell blue subnet, I need to add a route to the blue subnet, the blue to a virtual appliance net and our blue work in your environment. In our example that we have here of our red net and our blue subnet, I've checked, and in this example, rather than routing the traffic, both having access to the internet, I want to force the blue subnet traffic to traverse through the red subnet appliance before it goes to the internet. So I don't want the blue subnet to have internet access. And so if I want to do this in this configuration, what I need to do is I need to add a route table. And when I add this route table, then I tell blue subnet, create my routing table, I add my custom route where I say, if you're trying to get to the internet, blue subnet, go talk to red subnet to the gateway appliance, and I associate this with the blue subnet. And then when that occurs, I've got my route forcing the traffic back through the appliance, and blue subnet will route the traffic through the red subnet. Now they can both still see each other because that's built into this, but you can override them with a route table. The traffic out. And so let's take a look at when you go to create a route table, you're going to attach it to a resource. And typically you're going to enable route propagation. The only reason you might not want to enable route propagation is if you were to have some kind of routing protocol running within your environment and you want to manage the routing updates manually because you have a really complex environment, then you probably want to turn it off. But by default, typically you're going to enable it, and that's going to allow all of the routing within your subscription to be aware of what's going on within the entire subscription. And then when we create our route and have that route either route to a virtual network gateway, to another virtual network. So maybe I have multiple devices that I want to pass traffic through for some reason. I can route it to the internet or virtual appliance, or I can remove the route. So I can say this network has no route to the internet. The servers will not be able to see the internet. And so you can turn off that by adding a custom route. And so there's something to think through in your planning and in your discussions with your security team. What is the standard that you want to set up for the design of your servers? Are you okay with servers having access to the internet? Or do you want to maybe front end them with a firewall? Or you can even route the traffic back to premise and then route it out your corporate network if you had a corporate firewall that you wanted to route the traffic through. You can traffic back through there. And around networking and network interfaces. This completes this video lesson. I'll see you in the next video lesson.
Hey, and welcome, gurus, to lesson 2 in the network traffic management section of this course. There is and why we might use it. We're then going to discuss the features, facts, and implementation steps of Azure Load Balancer. We're going to take a load balancer architecture, and we'll wrap up this lesson with a demonstration of configuring Azure Load Balancer. So let's get started. So what is Azure Load Balancer? Well, it's a layer 4 TCP and UDP load balancer that provides high availability by distributing incoming traffic amongst a pool of healthy resources. So what does that mean? And also, why would we use an Azure Load Balancer? Well, for example, if we highly available and provide users with session persistence so that they can fill out their forms and access their data, we can balance this traffic across a pool of virtual machines that all have this web portal. Before network load balancing, what we would have to do is we would have to send all this traffic to one machine to handle all of this, and it might overload it and then bring the machine down, and that's not a highly available solution. So with the Azure Load Balancer, we can sit here and distribute the traffic amongst the VMs in the backend, and what will happen is if we probe and detect that one of the VMs is not healthy, it will then route around that and send the traffic to the healthy instances so that we have a solution for that web portal. So now that we know what Azure Load Balancer is, let's take a look at some of the features, facts, and steps of implementing Balancer. Are that it's a layer 4 TCP UDP load balancer. So we're not going to be balancing traffic at layer 7 like with an application gateway, which we'll learn about in a later lesson. And it also provides us a highly available solution. Now, this is because of that health probing and being able to balance the traffic via the distribution rules that we set up on that load balancer. We can also deploy our load balancer with an application traffic, but what Azure Load Balancer is and why we might use it, let's take a look at some of the features, facts, healthy instances, so that we have a highly available solution for that web portal. So now that we know what Azure Load Balancer is and why we might use it, let's take a look at some of the features, facts, and steps of implementation for Azure Load Balancer. So some key features and facts about Azure Load Balancer are that it's a layer 4 TCP UDP load balancer. So we're not going to be balancing traffic at layer 7 like with an application. It also provides us a highly available solution. Now, this is because of that health probing and being able to balance the traffic via the distribution rules that we set up on that load balancer. We can also deploy our load balancer into an availability zone, or we can use availability sets. Now, deployments in availability zones will protect users, whereas the availability sets will provide protection from hardware failure inside of a data center. We also have the feature of health probes, and the health probes are going to be either for TCP or HTTP probes. The TCP probe is the equivalent of our load balancer pinging the machines in the backend pool to see if they're up. And the HTTP probe makes a GET request for a file such as a health.html to determine the health of our backend machines. Now, we also have 5-tuple hash as the default distribution. 5-tuple hash is consistent of the source IP, the source port, the destination IP, the destination port, and the protocol type. So if you're trying to provide the maximum session persistence for your session affinity, you might want to use a 2-tuple hash so that your end user stays glued to a single instance during their entire experience, because a 2-tuple hash will just consist of the source IP and the destination IP. And then on top of this, we can use Azure Load Balancer for internal and external load balancing. An example of internal load balancing would be balancing traffic between database servers that are not publicly accessible, that are only accessible from the virtual machines that are running our web server that are behind a public load balancer. So now that we've talked about some features and facts, let's talk about the implementation steps. So to create a virtual public load balancer. So now that we've talked about some features and facts, let's talk about the implementation steps. So to create a load balancer, that's the first thing we do, is create it. But first, we have to have the prerequisite virtual machines inside of that backend pool. We then would configure the health probe and choose between our solution. So now that we've talked about the features, facts, and some implementation steps for load balancers, let's go ahead and take a look at an architecture. So here in our more formal architecture than what we looked at before, we see we have our load balancer, and behind our load balancer is a pool of 3 virtual machines. This is all deployed inside of a virtual network, and the load balancer has a public IP address that our end user will access. And it will send traffic to the load balancer from that public IP, and the load balancer will have to make a determination between the backployed inside of a virtual we looked at before. We see we have our load balancer, and behind our load balancer is a pool of 3 virtual machines. This is all deployed inside of a virtual network, and the load balancer has a public IP address that our end user will access between the backend pool where to send it. And it follows this using our distribution rules. And then we might have session persistence set up so that this end user can stay connected to this single virtual machine. All the while, we have probes checking to make sure that our virtual machines in the backend are healthy using either TCP or HTTP. So now that we've taken a look at the architecture and have an understanding of what Azure Load Balancer is and what it does and why we might use it, let's go ahead, jump into the portal for a quick demonstration where we will implement our own Azure load balancer. All right, gurus, so here we are in the Azure Cloud Sandbox. And what I've done is I went ahead and provisioned the virtual network and 2 virtual machines inside of a web subnet for us. And then I disassociated the public IP addresses that were attached to these virtual machines. They were basic SKU Azure load balancer. So I would either have to have standard SKU public IPs, or I just disassociate them as I did. So let's add this load balancer into this solution so that we can balance between these 2 web servers that are going to be telling us what VM they are based on their host name. So if we head up here and we type in load balancers and select load balancers, then click create load balancer, we are now in the creation process. We'll select our resource group here, and this is going to pre-fill the region for us for our solution because it's going to pull it from the resource group. And then what we're going to do is we're going to name it. We'll name it load balanced. And then we can choose our type between internal or public. We need this public facing because we need the public IP. And we can choose that you can balance between backend pool flexibility with things such as high availability ports and zone redundancy. And also you get to use either standard SKU public IPs or no public IPs with your solution. So we'll choose standard, and standard is by default secure. So you're going to need to use network security groups to explicitly permit and whitelist allowed traffic. Otherwise, use basic. If we were using basic, we wouldn't have to do so. We wouldn't need the network security groups, and this public IP address would be white. So we're choosing standard. We're going to create a new public IP address, and we'll call this load balanced IP. And then we'll come down here. We'll choose availability zone of zone redundant to enable this feature. And we'll go ahead and click review and create, finish provisioning. Okay, gurus, so we're back and our load balancer has finished provisioning resource real fast, and take a look at our front-end IP configuration. This is already set up because we created this public IP address when we provisioned the resource, so we can skip this step and head straight into creating our backend pool. So we need to add the virtual machines that we created into our backend pool. We're going to name this pool BE pool, and we're going to put it inside of the CloudChase VNet that I already have created. And then we're going to leave it for IPv4. We could choose to add our virtual machines or virtual machine scale sets to balance between scale sets, which you can do with the basic or standard SKU load balancer if we had scale sets, but we just have the virtual machines. We'll click add, we'll choose both, and we'll click add, and it's good. We'll head back to the load balancer, click on standard. So the request 2 consecutive we'll do, and we are going balancing rule now, and we're going to name what we will do the balancer to the backend port of 80 for this backend pool. We're going to use this health probe, and for our session persistence, we could choose client IP, which is our 2-tuple hash, and client IP and protocol, which is our 5-tuple hash. We're going to choose none, and then all we have to do now is click OK. And it's going to create this load balancer inbound rules instead of just inbound NAT rules. And this would be useful if we were trying to allow inbound NAT rules for SSH or outbound rules so that backend web servers could update themselves from the public IP address of our load balancer. All right, gurus, so we're back. Our load balancing rules finished. Our health probe is set up. Our backend pool has been added, and our front IP configuration was created when we created the load balancer. So let's go to the overview, click the public IP address, and paste. Remove all of that right there. Hit enter, and we see we just accessed CloudChase VM1. So let's copy this real fast and check it in another browser and see if we can be load balanced. And we are. We're hello world from host CloudChase VM to setting up a load balancer. So let's head back to the slides, head back to the from host CloudChase VM2. So we just balanced between 2 virtual machines, setting up a load balancer. So let's head back to the slides for a quick review. view.